All right, so today we're going to start our 9th unit, and we're going to talk about transformations. And like we said in class today, this is not like your 6th grade transformations. So you're going to learn what the different transformations are. You're going to learn what an isometry is. You're going to learn about vector notation and how to translate a figure in a coordinate plane. So transformation is just taking a geometric figure or any kind of figure, changing its position, its shape, or its size. The 4 different types that we're going to learn about this year are translations, reflections, rotations, and dilations. And you learned these all at one point earlier, but we're going to make them do a little bit more with them. So the first thing you have to know is you have to know the vocabulary. First, the preimage is just our original figure. Our image is our figure after its transformation. If we have a preimage P, and we're going to take this point P, and we're going to translate this point P to up here, we call that P, and we use a little tick mark to mean P prime. If I were to move it again, I can use 2 of those tick marks and say P double prime. An isometry is just a transformation where the preimage maps to the image. What I mean is there is no change in the size and no change in the shape. So we're going to have the same size and shape. Our orientation can change, where it is can change, but its size and its shape is going to stay the same. So the first kind of transformation we're going to talk about is a translation, and that's just taking a figure and we're just going to slide it. So you had it called a slide. Can you read that? When you were in 6th grade or earlier, you talked about slides. So if I take my knee lion and I just move him up and then down, that's a translation. I've just slid them around my page. Okay. We can express that by using arrow notation. So this, taking our x and y coordinates, for our x I add 3, the y coordinate we're going to subtract 4. So that means I move it 3 figures to the right and 4 down. Okay. Just real simple notation. So here I have this graph, and I want to graph this preimage, and I want to graph its image under that translation. So minus x minus 1 means I move it to the left 1. Plus 4 means I go up 4. So I take each point. So I take my A and I move it over 1 place and then up 4. Okay. 1, 2, 3, and 4. So we're going to be right here. And that's going to be my A prime. B, if I move it left 1 and up 1, 2, 3, 4, it's going to be right here. And that's going to give me B prime, and then I can just connect the line. Okay, and then C, I'm going to move it left 1 and up 4, 2, 3, 4, and there's C prime. Okay, whoops. And if I connect my dots, here is my image. Remember what we started with is our pre-image. And I've used the tick marks to mean the primes to show that it's been translated. Okay, sometimes we use vectors. And vectors are just a quantity with a direction and a magnitude. And in fact, when I made my little Nittany Lion move, PowerPoint uses a vector. I just draw the vector and it takes it where it wants it to go. Takes my image, my preimage, and moves it to where I want my image. So this is an example of a vector. This is my starting point, and this is what we call our terminal point. And that arrow actually doesn't go anywhere. This is where it actually ends. So if I start here with this vector, I'm going to move 4 to the right, and I'm going to move up 2. So we would write that as 4, comma 2. And notice I'm using these things that look like greater than signs and less than signs. That tips me off right away that that's a vector, just like parentheses tip you off that it's an ordered pair. So if I have 3, negative 4 as this, it means that I'm going to go right 3 and down 4. So it's just another notation for you guys to know. So I have this point 7, negative 3, and I want to find the component form of the vector that describes the translation p to p prime. So what that means is I'm going to use this form. Okay. So if I'm going from 7 to 10 and then negative 3 to 15, I can just subtract to see where how it's going to change. So t minus 7 is 3, so that I'm going to go right 3. And then 15 minus a negative 3 is 18. So I'm going to go up 18. So this is my vector that translates my pre-image onto my image. For part B, negative 11 minus 7 gives me negative 18. Seem to like that number today. And then 20 minus a negative 3 gives me 23. So there is my vector that would map that 0.7, negative 3 onto negative 11 and 20. Okay. So here I have triangle ABC, and I'm going to translate it by the vector negative 4, negative 3, which means left 3 and down, left 4, I'm skipping ahead, and down 3. So I'm going to take my A and I'm going to go left 4. There's 1, 2, 3, 4. Okay, and there's my A prime. No, it's not my A prime. And then I'm going to go down 3. 1, 2, 3. And here is my A prime. I don't need those anymore. B prime, I'm going to go left 4. 1, 2, 3, 4. And down 3. 1, 2, 3. So there's my B prime. And C, I'm going to do the same thing. And it's going to take me left 4 and down 3. And if I connect, there is my image. Sometimes if I've got a lot going on, I shade just so I can pick that up more quickly visually. Okay, so I have the dashed line figure. Another example is a translation of our solid figure. So what is our translation? What's our transformation? So if I go from X to X prime, I'm going to go down 3 and to the right 4. So for vector notation, it would be 4, negative 3. And if I were to use arrow notation, the ordered pair X, Y maps onto X plus 4 and Y minus 3. So those are just two different ways to notate this. Okay, so today we kind of introduced transformations. We took a look at some of the vocabulary that you need to know, and then we did some translating. I hope you guys have a great day, and I'll see you guys after break.